Maxwell House coffee. It's good to the last drop. This can, of course, if we were to put it on the table, as we've been studying about energy, if I were to give it a roll across the table, we would expect it to slow down as it goes because of the friction and air resistance, and it would slow down as it comes down to the edge of the table, and then probably roll off the end of the table. So let's see what happens here. And wait a minute. Okay, let's try it again. Strangely enough, this can of Maxwell House coffee wants to come back. And if you're a smart physics student, you'll realize that's impossible, right? You don't have things like this happen without an explanation. If we get a weird effect like that, there's a cause of it. And the cause is, if you're paying attention closely, you might see some rubber bands sticking out the end of this can. Inside this can, if you look carefully, you'll see I have a weight. It's almost like a little piece of pipe hanging from rubber bands. And so what happens is, as I roll the can across the table, right, the rubber bands are winding up. The weight is being held with inertia essentially down at the lowest point, and the rubber bands are winding up. Elastic potential energy is stored in the rubber bands, and then when there's enough elastic potential energy stored in the rubber bands, and the energy of kinetic energy has been stored in it, then the can, when it's released, that potential energy will come back out in the form of kinetic energy, and it'll come back down to the other end of the table. So energy is conserved, but this can is a comeback can.